Hello, my name is Sabrina, and today I'll be presenting our research investigating if cannabis use worsens glutamate dysfunction in people with schizophrenia. To begin, cannabis use has a worldwide prevalence of almost 5% among ages 15 to 64. Importantly, a relationship between cannabis use and an increased risk of psychosis is now well established. One of the suspected biological changes underlying psychosis is glutamatergic dysfunction. Magnetic resonance spectroscopy studies indicate increased glutamate levels with acute cannabis use, followed by glutamate reduction with longer use. In this study, we test if there is a dose-effect relationship between cannabis use and the levels of glutamate in schizophrenia, indicating a possible mechanistic overlap. We hypothesize that patients using excessive cannabis would display much lower glutamate levels. Our methods included recruiting 31 first episode schizophrenia, or FES, participants and 59 healthy controls. FES participants met inclusion criteria of an antipsychotic exposure of less than 14 days and were recruited via referrals from the Prevention and Early Intervention for Psychosis program at London Health Sciences Centre. MRS was collected using a Siemens 7T head-only MRI scanner and a site-built head coil from a dorsal anterior cingulate cortex voxel. The metabolite fitting template collected glutamate from each participant during resting state. To determine cannabis use, the 6-item Likert scale self-report cannabis abuse screening test, or CAST, was used. Scores range from 6 to 30, with higher scores indicating more cannabis use. Bayesian regression analyses were used to identify any influence of cannabis use operationalized by CAST scores or group, which included FES versus healthy controls on glutamate levels. We first regressed glutamate as the dependent variable onto CAST scores and group, then onto CAST scores and FES only. In both regressions, posterior distributions were estimated using the general test BF function in the R Bayes factor package. Bayesian analyses found that the null model outperformed models showing a relationship between cannabis use and ACC glutamate. Glutamate was regressed on cannabis use with a Bayes factor of 0.81 and group, indicated in figure 1, with a Bayes factor of 0.3. We found that group, shown in figure 2, and cannabis use did not outperform the null models. Glutamate regressed onto cannabis use and only FES participants also did not outperform the null, shown in figure 3 with a Bayes factor of 0.81. Therefore, both cannabis use and group do not have any effect on ACC glutamate. This study provides evidence against a relationship between ACC glutamate and cannabis use in schizophrenia. It is possible that cannabis-related increase in risk of psychosis operates through pathways other than glutamate dysfunction. This work has several limitations, including the low number of cannabis users in the healthy control group and the use of a single voxel template, which could have missed glutamate relationships in other brain regions. Future research should explore a larger sample of FES patients and healthy controls with cannabis use with objectively quantified cannabis exposure. If you'd like to reach me, I'd be happy to chat and answer any questions at sabrina.ford@lhsc.on.ca. Thank you for listening.